we will continue EPA 608 Universal Certificate, now in core of refrigerant oils. Now we are in refrigerant oil. We finished the last one is refrigerant blends. Now we are in refrigerant oils. Let's start.
In this module, we will introduce refrigerant oils and talk about how they are used in HVAC systems.
In HVAC systems, we use refrigerant oils in the compressor. As refrigerant moves through the system, it will carry some of the oil with it. But ideally, most, if not all, of the oil should be in the compressor. To recall what we learned earlier, the compressor's role in the refrigeration cycle is to increase refrigerant pressure. As it increases refrigerant pressure, the temperature of the refrigerant also rises. As the temperature of the refrigerant increases, the components of the system heat up as well. This is where refrigerant oils come in.
What are refrigerant oil found? Where are refrigerant oil found? It's found in the compressor.
In the compressor, refrigerant oils are used to lubricate the system, remove excess heat, and seal the system. The main purpose of refrigerant oils is to lubricate the components in the system. Lubrication helps the components move smoothly even as the temperature and pressure increase. In the compressor, refrigerant oils are tasked with carrying heat and contaminants away to ensure it keeps running optimally. Finally, refrigerant oils help seal the system. They help prevent refrigerant leaks in the equipment, which can reduce the system's efficiency.
What are refrigerant oil used for? Lubricating the system, removing excess heat, and sealing the system. Yeah.
When technicians are trying to diagnose what is wrong with the system, they may choose to take a sample of the oil and send it in for testing. Oil samples give you valuable information on what is going on inside the system. Technicians may want to take an oil sample if they suspect the following culprits: moisture, acid, oil sludge formation, and oil waxing. Moisture can react with oils in the system to degrade the oils. An oil sample will tell you if this is going on in the system. Acid can break down metal system components, which causes major failures. Technicians should be especially aware of acid after a compressor burnout. When a compressor experiences a burnout, residual acid can contaminate the oil in the system. Taking an oil sample will confirm if there is acid. Refrigerant oils can decompose in the system due to a variety of factors. When this happens, they turn into a sludge. Decomposed oil can no longer do its job and causes the system to run inefficiently. Taking an oil sample helps technicians confirm whether this is happening. It is important to take an oil sample after a major component failure or leak. This includes in the case of a compressor burnout, which we will talk more about in the next chapter. In this module, we looked at the purpose and properties of refrigerant oils. We also discussed the different types of oils and their applications.
Now we'll go to the next part, this refrigerant oil properties.
In this module, we will discuss the purpose of refrigerant oils and their properties.
The main purpose of refrigerant oils is to lubricate the system. In previous modules, we learned how the refrigeration cycle goes through pressure and temperature changes. Refrigerant oil needs to be able to lubricate the system efficiently through different temperatures and pressures. Refrigerant oils need to be durable enough for real-world use. They cannot break down or decompose when exposed to varying temperature and pressure changes in quick succession. In order for refrigerant oils to do their job, it is important to consider the following properties: viscosity, miscibility, hygroscopy, hydrolysis, and flammability. Oils have different levels of viscosity. Viscosity refers to how thick an oil is. The thicker an oil is, the slower it will flow. For example, water poured over a pan flows faster compared to olive oil poured on the same pan. The oil flows more slowly because it is more viscous. The more viscous an oil is, the harder it will be for it to move refrigerant quickly through the system. A viscous oil will struggle to transfer heat through the system via refrigerant, which defeats the whole purpose of the refrigeration cycle. Miscibility refers to how well the oil mixes with and carries the refrigerant. Refrigerant oil needs to be miscible with refrigerant. This means it needs to mix well with refrigerant in order to efficiently transport it around the system as it does its job of transferring heat. If an oil is not miscible with the refrigerant in the system, it will cause inefficiencies in the refrigeration cycle. It can also make equipment fail since it adds a lot of stress to it. Many of the oils we use today are hygroscopic. This means they attract and retain moisture. This contaminates the system, so we need to keep these oils away from moisture. Moisture in a refrigeration system can cause serious problems. Water in the system can freeze, creating a physical obstruction in the piping. It's like a blood clot of sorts. This can negatively impact the cooling efficiency of the system. Hydrolysis is the process through which water chemically breaks down another substance. For our purposes, we will focus on how water reacts with refrigerant oils. Some oils will react with water and decompose into acids and alcohol. Both these substances can cause significant damage to equipment components. Acid, for instance, may corrode and damage the metal components inside the equipment. Technicians must also consider that refrigerant oil runs through the system millions of times, so it must be durable. It cannot decompose, even after running millions of times through the refrigeration cycle. There are a lot of units that have been operating with the original refrigerant and oil for 30 to 40 years. Systems can function well with proper design and maintenance. In order to operate safely, refrigerant oils must not be flammable or explosive. They must be able to withstand the system's most extreme temperatures and pressures. To determine what oils should be used, there are flammability tests that can be performed. These tests are conducted by organizations like ASHRAE, which provide guidelines on the right oils to use in different systems. The technician just needs to follow these guidelines and understand where they come from.
An ideal oil is readily miscible with the refrigerant in the system. Yeah. This statement is true. Oils need to be miscible or mix well, okay, with the refrigerant in the system. As long as oil not flammable at the starting and ending temperature, it can be used because the system is contained. True. This is incorrect. Oh, oil need to be non-flammable at all temperature, okay, and pressure of the system. Okay, the question, as long as oil is not flammable at the starting and ending temperature, it can be used because the system is contained. An ideal oil is the best at heating only high temperature and high pressure. False. Yeah. Hydro Hydrolysis is when refrigerant oil break down in the pressure of water. I think it's true. Yeah. Hygroscopic oil break down in the presence of water. Yeah. Absorb moisture readily. Reject moisture. Okay, I think this one. Oh, not this one. Okay. Absorb moisture. Yeah. Hydroscopic oils absorb moisture easily.
In this module, we looked at the purpose and properties of refrigerant oils.
Okay, let's go to the last part in refrigerant oils, and after this we will have the quiz. Okay, let's go to types of refrigerant oil. Type of refrigerant oil.
In this module, we will discuss the different
Types.
types of refrigerant oils and their applications in HVAC systems.
There are two main types of refrigerant oils: mineral oils and synthetic oils. Mineral oil was first derived from petroleum refining processes. It is produced as a byproduct when crude oil is distilled to produce gasoline. Mineral oil was primarily used with the older generation of refrigerants, including CFCs and HCFCs. Mineral oils were great for the earlier generations of refrigeration systems, which ran on CFC and HCFC refrigerants. As the industry phased out CFCs and HCFCs, it had to develop new oils to use with the new refrigerants. These new oils are called synthetic oils. Synthetic oils are manufactured from processed petroleum and given highly specific properties to make them compatible with new refrigerants. Synthetic oils are required on retrofitted equipment because mineral oils are not miscible with modern refrigerants. Synthetic oils include alkyl benzene, polyester, polyethylene glycol, and polyvinyl ether. Each of these synthetic oils are used with different refrigerants. Earlier, we discussed why a refrigerant oil needs to be miscible with the refrigerant in the system to work efficiently. For example, let's say an oil is used in a system with HCFC refrigerant. For it to work efficiently, it has to be miscible with HCFC refrigerant. Alkyl benzene is a synthetic oil used in refrigerant systems with CFC or HCFC refrigerants. As we discussed previously, CFCs and HCFCs have been phased out, but HCFCs are still used in some refrigerant blends. As such, refrigerant blends containing HCFCs use alkyl benzene oil to service the system.
Alkyl benzene AB AB oil is used for system with which of the following refrigerant? Okay, I don't remember this one. Incorrect. Alkyl benzene is used with systems that contain CFC and HFC. Ah, both. Okay. Alkyl benzene AB oil is miscible in HCFC refrigerant. False. Ah, true. It's miscible. Okay.
Polyester is a synthetic oil used in refrigeration systems that can be called ester oils. This means that if a system is retrofitted with HFC refrigerant or HFC refrigerant blends, it will need to use polyester oil. We learned earlier that retrofitting means to modify a system to use a new refrigerant. Polyester oils, or ester-based oils, cannot be mixed with any other oils. This is something technicians have to keep in mind when servicing equipment running on ester-based oils.
If we retrofitting system to use R134, which oil do we need to use? I think this one. Yeah, polyester oil. Polyester oil are great because they can mix with a lot of oils. True? No. Polyester oil cannot mix with any other. R1234YF is not mixable with any refrigerant oil. I think it's true. No? Oh.
Polyethylene glycol is a synthetic oil that is
Are
used
mixable
mainly
in
in car air
POI.
conditioning systems. And lastly, polyvinyl ether is a synthetic oil that is mostly used as an alternative to POE oils. In this module, we discuss the different types of oils and their applications.
Okay, now let's check the quiz. Okay, attempt the quiz. We have 10 questions. Okay, let's start with this one. Alkylbenzene AB oil is used for system with which of the following refrigerant? HCF, CFC, and HCFC. Okay. I will not remember this one. Which of the following characteristics do hygroscopic oil have? Break down into presence of water, absorb moisture readily. If we are retrofitting a system to use R134A, which oil do we need? I don't remember this one, but I don't remember. Mineral oil? I don't know. Let's check again after we finish the questions. R1234YF is not miscible with any refrigerant oil. Yeah. Alkylbenzene oil is miscible in HCFC refrigerant. False. An ideal oil is the best at handling only high temperature and high pressure. False. An ideal oil is readily miscible with the refrigerant in the system. An ideal oil is readily miscible with the refrigerant in the system. An ideal oil is readily miscible with refrigerant in the system. True. I'll check this one also. Provide that the oil is non-flammable at both the initial and final temperature. It is suitable for use since the system is enclosed. True. Hydrolysis is when refrigerant oil break down in presence of water. I'm trying to remember this one. Hydrolysis is when refrigerant oil break down in the present. True. Polyester oil are great because they can mix with a lot of oil. True. Let's finish this up then. Okay, let's submit. Okay. So many mistakes in this one. Okay, this one was wrong. Okay, it's not mineral. Okay, and this one. No, this is different. Okay, and this one. Okay, we can revise it again. I'm trying to open so we can pause the video and revise it again. And this is the last. Polyester cannot mix with any of oil. Okay, let's return. Let's review. Let's go to the next one. This equipment. Okay, equipment classification. We will continue here in the same video, the equipment classification.
In this module, we will take a look at the properties of the equipment used in HVAC systems.
We look at the pressure of the refrigerant when it is in liquid phase to decide what level of pressure the appliance operates at. The levels of pressure in appliances can be categorized into 3 types: high, medium, and low. A refrigerant's pressure is determined by the pressure of the appliance it is in. For example, a refrigerant used in a low-pressure appliance would be a low-pressure refrigerant. This is how we classify the pressure of refrigerants according to Section 608 regulations. Examples of refrigerants used in high-pressure appliances include R22, R407C, R410A, and R502. Any one of these is considered a high-pressure refrigerant. Examples of refrigerants used in medium-pressure appliances include R12, R134A, and R500. Any one of these is considered a medium-pressure refrigerant. Examples of refrigerants used in low-pressure appliances include R11, R123, and R113. All of these are considered low-pressure refrigerants.
We measure the pressure of refrigerant when it is in vapor phase, false in liquid phase, liquid state. Refrigerant pressure in appliance can be categorized into low, medium, and high. True. Which of the following refrigerant is used in medium pressure appliances? Medium pressure R11, I think. R13, R11. I don't remember this one, but R113.
Earlier, we learned that recovering refrigerant refers to the
R12.
process of
R12. Okay.
evacuating refrigerant from a system and storing it in a container. There are 2 main types of recovery: system-dependent recovery and self-contained recovery. The type of device used depends on the type of recovery required for the specific system. System-dependent recovery is kind of how it sounds. The recovery process depends on the system. This process of refrigerant recovery uses the pressure of the compressor to recover the refrigerant. In other words, the process relies on the system, hence why it's referred to as system-dependent. Earlier, we discussed how refrigerant flows from areas of high pressure to areas of low pressure. This is similar to how heat flows from a high temperature medium to a low temperature medium, like from your hot, steaming mug to your hands. The compressor, by default, creates a lot of pressure. If you connect the compressor to a low-pressure container, refrigerant will naturally flow from the high-pressure compressor to the low-pressure recovery device. System-dependent recovery typically depends on the compressor's pressure. When you use a recovery device that uses this method of system-dependent recovery, it is referred to as a system-dependent device. Self-contained recovery is the opposite. It does not rely on the pressure of the compressor or any internal components. It recovers refrigerant without relying on the pressure of the compressor or any internal components. In this module, we discussed how to classify appliances based on their operating pressures. We also define different types of refrigerant recovery devices.
Okay, equipment and components.
In this module, we are going to take a look at the different types of equipment used to service HVAC systems.
A manifold gauge is a tool commonly used by technicians to service HVAC equipment. It is used to measure the pressure and temperature within the system. Another name for a manifold gauge is service manifold. In the center of the manifold gauge set is the yellow hose, which is the center port. The yellow hose is used for evacuation, recovering, and charging. Color coding on the manifold gauge means the following: blue gauge, low pressure side; red gauge, high pressure side. The high-pressure side, color-coded red, of the service manifold can read pressures ranging from 0 to 800 psi. The low-pressure side, color-coded blue, of the service manifold shows pressure in units of pounds per inch 2 gauge and inches of mercury.
What color is the high
If
pressure
a
side
piece of
of the
equipment
manifold? The
contains
red one.
CFC or HCFC refrigerants, Section 608 requires it to have a process stub. A process stub is a typically straight piece of tubing that provides access to the refrigerant inside an appliance. It is normally resealed after the appliance is serviced. The purpose of a process stub is to make it easier to recover refrigerant. It is sometimes referred to as a service aperture. In order to make sure that the system is completely safe to use, we need to replace any components that are in danger of failing. This way, we prevent major failures that can create life-threatening situations. Safety should always be the first priority. Relief valves are installed to provide insurance in case pressure builds up in the system. If the pressure rises too high because of irregularities in the system, it can result in a major explosion. This, quite obviously, is a grave safety concern. If the body of a relief valve shows any sign of corrosion, the whole component must be replaced. Corrosion on the body indicates damage that may prevent the relief valve from doing its job properly.
Which component provide access to refrigerant inside an appliance? Relay valve, manifold, gauge, hose, process. Access to refrigerant inside an appliances. This manifold? No, this manifold for shaking. Okay, no. Yeah, process stop is straight piece of tubing that provide access to the refrigerant inside the appliances that contain CFC
In this
and
module, we looked at the different types of
HCFC
equipment
refrigerant.
commonly used to service refrigerant systems. We discussed the main conventions, procedures, and specific properties of the devices we use in this trade.
Okay, this the last part is equipment malfunction.
In this module, we will discuss the procedures to follow when equipment malfunctions.
In the event of a compressor burnout, we need to first assess the damage, then clean it up. A compressor can burn out from extremely high temperatures, which may result in its components failing. If a compressor burns out, the oil turns highly acidic and produces an acidic smell. The burnout can be severe or mild, which is why the technician needs to assess it first. If you suspect a burnout or any major equipment failure, you need to take an oil sample. An oil sample will give you more details on what is wrong with the system. To clean up a system after a burnout, it is important to do the following. Install a liquid line filter dryer, install a suction line filter dryer, and flush the system with dry nitrogen. After a compressor burnout, we need to flush the system with nitrogen to get rid of oil residue in the purge lines. Alternatively, we could also use a commercial system flushing solution. Both of these are approved methods of cleaning up. We cannot flush with liquid refrigerant to clean the field tubing. This would vent the refrigerant, and under Section 608, this is illegal. Faulty components must also be replaced so that the system can function again.
If you suspect burnout, an oil sample can over more detail on situation.
The compressor's crankcase
Yeah,
acts as a container that collects refrigerant oil in the refrigeration system. When the system is not running, the refrigerant does not have any force or pressure acting on it. Because of this, it will naturally flow to where there is the least amount of pressure. Imagine you are juggling some oranges. As you juggle them, the oranges move in a circle in the air because your hands propel them in that particular motion. If your hands stop moving, the oranges will fall to the floor. That is the natural force of gravity acting on them. In the same way, if the refrigeration system is not running, refrigerant will flow to the place with the least amount of pressure. This place happens to be at the crankcase. The oil pressure in the crankcase is lower than the refrigerant pressure. This is why refrigerant will migrate to the crankcase. This is also similar to how heat will travel from a high temperature medium to a low temperature medium, as we discussed in the refrigeration cycle. To reiterate, the refrigerant will migrate to the crankcase in the compressor because it is the place with the lowest pressure in the system.
refrigerant migrates to the crankcase because it is the point of the highest pressure in the system.
Refrigerant pipes are made
False.
of metals like steel and copper.
It is the
We
lowest
have to
pressure.
be mindful of how refrigerants interact with copper, especially because copper components can be oxidized by refrigerants. In this module, we learned about the malfunctioning of equipment and discussed different ways to avoid it.
Okay, now we finished both refrigerant oil and equipment. Okay, so The next video we will continue servicing and leaks.